We're now going to code the base movement on our playable character, and we want to approach that in a smart way. Even though the base movement code to move on the ground is going to be simple, we know that our character will have a number of behaviors, the ability to move, but also to jump and to bump against rocks. When you have multiple behaviors like these and the character can transition from one to another, often it's a good idea to apply the state pattern or the simplified version we're going to use here called making it a stateful object. It's an object that has a list of states it can be in. Let's take a door, for example, or a chest. The door can be closed, the player can be opening it, or the door can be opened. So you can have 3 states with some kind of transition in between, or 2 states. You have closed and open, and when you open the door, you play the open animation, for example. That's the idea between using a finite state machine. There's a finite number of states or behaviors the character can have, and it can be in one at a time only. And we separate these behaviors into separate blocks of codes, or when you use the state pattern, the for one, you separate them in individual files that are small and self-contained. But as our character is going to be fairly simple, we're going to put everything in one file, which can work well for simple objects in your game or also in game jams or situations like these. We'll need to work on 2 scenes. We have the player, but we'll also need to work on the character base scene, which will define the code that handles transitions between states. So let's go to the character scene, and we're going to create a new script on it. So you can select the character, press the add script icon, and the convention I've chosen for this course was to have lowercase for GDScript files. You can keep Pascal case obviously in your case, no problem. Let's create that script. We're going to remove almost everything and start defining our character's code. So let's define what all of our characters will have. To have this state pattern, we're going to have some variable called state that can change and that will define which state the character is in. And we'll start with a state of 0. So for the states, to track them, we'll use enums in Godot. And enums are lists of constants that we can create. So let's create a states enum, for example. I should use Pascal case to create a states enum, and then you can add constant names. Let's say idle, walk, for instance, and Godot will assign integer values to each of these constants. What matters is that then in our code, we can call them this way, or we can write rather the name of the enum dot the member variable, the constant that we want to access. Now, we're not going to define that enum on the character script, because then we can't redefine it on a child class, which is a limitation of how enums work. So instead, we're going to define our state variable as an integer value, which will work with enums, and 0 will be the base state, and in general, in your games, it will be the idle state. That's what I would recommend. Then, a state machine can work with or without transitions. Typically, if you want the full pattern, you'll want to define transitions. Your transitions will be a list of possible starting states and events that the state machine receives, and the resulting state the character will end up in. Something under the form, let's say, for example, so if we are in the idle state and we receive the event move, we will go to the walk state, something like that. So we will define on the left side, the key for the dictionary will be the thing that triggers the transition. We'll define what starting point, starting state or behavior you want the character to be in, and the event that we give to the state, and the state the character should transition to. So these transitions we will define on the child script. To use this state and transitions variable, we're going to use a function called change state. And that's the one we will call every time we want to change the state of the character. The state being idle, not moving, or then will have move instead of walk because it's more generic, or jump, etc. And we'll change the state based on some event. Now, this event is not going to be, for example, pressing the key D or something like that. These events will take the input from the player, in the case of the player script, and will convert that input to some event like move, jump, etc. The reason being, our AI is not going to listen to the keyboard inputs. Instead, we want a generic system that will work for playable characters and non-playable characters, so events. You'll see how we create these events in the next video. But changing the state, we'll start first by storing the possible transition that we get from the current state of our character and the events that we receive as an argument to this function. So we're going to store that in a variable called transition, and I've showed you how these transitions would be based on some array with a couple of a state and an event. This is exactly what we're going to have here in our function. So we're going to use the current state of the character and the event that we get from the change state function. Then we want to check that the transition exists in the list of transitions. If it does not, the state machine won't do anything. So if there is not this transition variable in our transitions, we are going to return from the function. We are not going to change the state. Note that transition has an leading underscore. This means that this should work as a private variable. Once you've defined it on your character, external scripts, external systems should never try to access it. Only within this script or within the player script should you be able to define and access this underscore transitions dictionary. So then, if we get past that check on line 9, we're going to be able to change the state of our character. So let's assign the new state to the state variable. We're going to access the transitions dictionary, and as the key, we'll use our transition variable. And this will return a state, as we'll see in a second. Then we'll want to enter the state, and for that we're going to create a separate function, because entering the state will be a bit different in each of the scripts that we create. So let's create our enter state function. It's not going to take any argument. We're just going to define blocks of code in there for each of the possible states on our character. So in enter state, you will do things like changing the character's animation, resetting the height of the character after a jump to make sure that it's on the ground, etc. And for now, we'll just pass. So this function you want to override in every child class, in every class that extends our character file. We're going to do one last thing to first make our states label work, so we can display the state when it changes on the screen, but also just for completion's sake, we're going to add a signal. Let's move to the top of the script, and we're going to define a new signal, state changed, and we'll pass the new state, which will be an integer value for a whole number. Now we need to connect to that signal, so we are going to do that in the ready function. We are going on our character to connect our state label to this signal. In general, we're going to do it like that here for simplicity's sake, although you might want to, in a more complex game, add an initialize function on the state label and pass this node to the state label and let the state label connect itself. So this would be the clean way, quote unquote, to do signal connection, but sometimes when your scene is self-contained like that and the project is small or the scene is small, you can connect the other way around, connect from the emitter of the signal to the receiver. So let's connect state changed to our state label, and we will call on the state label. I have it open here, but you can press Ctrl-Alt-O to open the script browser and open state label there. And it has an on character state changed function. which we are going to call whenever the state changes. So the reason why you normally want to do that connection down in the state label script is because of this function name. If you want to change it at some point, this is going to create an error in this other script in another part of your code base. So that's why in general you will do something like that. You will create an initialize function, or let's call it setup, and it's going to take a character node, and we'll do the connect call here. So I'm going to copy the line on character.gd, go back to statelabel.gd and paste it, and we'll want to take character and to connect its state change signal to, now we replace getting the state label node with self, because we are in the state label script, and we call on character state changed. Note there is an error at the top of the script because our player script doesn't exist yet, but you don't have to worry about that. We're going to create it in a moment. And so once we've done that, once we've created that setup method, we're going to go back to character.gd, and we're going to get the state label node in the ready function, state label dot setup, and we're going to pass self as an argument. So the node just sends itself to the state label and lets the state label do all the connections and to connect to the right function. Now we have our signal, but we're not emitting it. So let's go down to the change state function, and at the end of it, we're going to use emit signal, and we're going to emit, hold on, I need to center the code on the screen, emit state changed. And there we go. We have our base character. We can now start working on the player.